What's going on everyone, you're back with Jono for another quick math lesson. Today we're going to look at expected frequency and how we can use that to make solid predictions about things in the future. This is the fundamental reason that probability is such an important mathematical skill for your real life. It goes way further than just the classroom. Being able to predict if something's going to happen based on prior performance or prior probability is something that is key to making sure that we're modeling things correctly. If we can nail down the probability of an event occurring, we can use this to predict the future. This is actually the basis for whole industries. Things like insurance, gambling, even prevention for natural disasters or something like COVID all come from the modeling of having the probability of something and then determining how likely it is to occur in the future. So for us, we need to remember that the probability of an event is what we want to happen or the event that we're looking for divided by the total possible outcomes that could happen or the sample space. And this is going to be kind of the foundation for our formula moving forward. So when we talk about expected frequency, we're talking about how many times should this thing happen in the future. And there are two things that matter. The first one is the probability of that event occurring. And secondly is how many times you run that experiment or you play that game. And this is all we really need to know. I kind of think about it like, even if I was a terrible free throw shooter in basketball, let's say I shot 10% from the line, eventually I would hit one. The only thing that's stopping me from getting one in is how many times I have a crack. So if I shot 1,000,000 free throws, I definitely would hit some of them, so I could work out how many I got in or my expected frequency of these events. So the probability and the amount of times you do it kind of intersect to tell us how many times we get that win. So the first really easy example is if we flipped 100 coins in a row, right? And then said, how many times do you think we'll get ahead? This kind of makes sense. You'd go, oh, it's a 50-50 shot, so we would expect to get about 50. So the actual formula behind this is just taking the probability, which is 50% or 1/2, and multiply it by how many times we actually did the flip, which is 100. So all we have to do is 1/2 times 100. If you throw that in your calculator, or we could just know that that's going to be equal to 50. So you can do that in your head straight away, but this formula, when it gets a little bit more complex, is what we've got to look at. So for this next example, I'm going to give you 18 rolls of the dice, and you'll win if you get a 6. So how many times do we think we're going to win in this example? So the probability is 1/6. 6 is the only outcome that can win it for us. And then we're playing 18 times. So that's the amount of times that we're doing this event. So all we have to do is 1/6 multiplied by 18. 18/6 becomes 3. And that's our expected frequency. We think we should win 3 times. So something that's really important to know is that the expected frequency is what we do before the game. Okay, this is how we predict what's going to happen. But this is different to what actually happens or the observed frequency. So I actually did that flipping the coin 100 times and these were my results. I got 43 heads and 57 tails. It is not a fair statement to be like, oh, your coin was obviously wrong, okay? It's not fair to say that, oh, if I did it 100 more times, you would definitely get 43% heads and 57% tails. There is just some random luck involved in this. But what it does help us do is guess what's going to happen the next 100 times. So this 50% idea is still really important to predict the future, but what we observe could be different and usually will be different. So I also rolled a die 18 times and wrote down how many 6s I got, and I got 5 6s. So I got lucky. I won 2 more times than I thought I would. But that doesn't mean that my die is loaded or there's something wrong with it. There is still a random chance to getting that outcome. And if I played 18 more times, maybe I get 3, maybe I get 0. But there is still some variability. The expected frequency just informs us what we should see in a very normal set of circumstances. So the word observed is what actually happens, what we physically see when we play the game, when we do the experiment. And something that we need to know is that the observed does not equal the expected when we're talking about the frequency. It can happen, right? You could flip exactly 50 heads, but it doesn't always have to. So one thing that's really important to know is that the more times you do an experiment, the more times you play a game, the more accurate your results become. And what I mean by accurate here is that the observed frequency will be closer to the expected frequency. And this is something that pops up all the time. This is why in science we make you do the experiment 3 times, because the more times you repeat something, the more likely you're going to get accurate data that represents what we thought beforehand. So if we're going to say that in maths language, as the sample size increases, so the amount of games, the amount of experiments we do, as the sample size gets bigger, the expected frequency and the observed frequency converge. And converge just means come together. So this is a fundamental idea about probability that you do have to get your head around, but I think you're going to find it all right. Thanks so much for watching, guys, and I'll see you later.